how long does it take to get to the same point from which you are right now while you're orbiting the moon 100 kilometers from its surface? That is, what is your period? To answer that question, you ask, how does the moon affect you? Well, the moon always exerts a gravitational force on you, which would cause you to crash into it if you weren't moving with some velocity v already. By the time you reach a certain point with this velocity, the moon forces you back through the force of gravity to stay on this circular path. And the force that the moon exerts on you, the force of gravity, is the gravitational constant times its mass times your mass divided by the distance from you and the center of the moon, for which the force of gravity starts, or called just the radius. Since it's the only force acting on you, it's also equal to your net force. And since it's a circular motion, it means that the acceleration is equal to your velocity squared divided by r. And the velocity is just the distance you cover divided by the time it takes for a full cycle, the orbital period that we're solving for. And the distance of a circle is just 2 pi r divided by the time to take to complete a full orbit. So rewriting all this a little bit more cleanly over here, two of the r's cancel out. And have two m's over here. Now you want to isolate t period on its own and everything else on different sides to solve for t. To do this, we can do this through 4 operations. Multiplying by t squared, multiplying by r squared, dividing by gravitational constant, and dividing by the mass of the moon. That way everything cancels out to the other side. Finally, your expression for the period squared will be 4 pi squared r cubed divided by g, the gravitational constant, and m. Now, solving for a final expression for t, taking the square root of both sides. The radius of the moon is just 1,737 kilometers. You want to make sure to use the same units while you're adding. Like units add with each other. It's meaningless to add meters to kilometers. This whole thing is cubed. And you want to add the gravitational constant in the same units. 6.67 times 10 to the negative 20 kilometers cubed. Seconds to the negative 2 and kilograms to the negative 1. Multiply by the mass of the moon. 7.35 tons, 10 to the 22 kilograms. You want to make sure all the units but seconds disappear. You're only left with the square root of 2 of seconds, which is 1. Finally, your final answer is going to be 7,066 seconds. To convert that to hours, divide by 3,600. Seconds cancel out. And you get about 2 hours. And notice, this is the same amount of sig figs that you started out with. 1,